morning. Good morning, everybody. I saw a question in the chat. I think that, yeah, I think you're right, Kayla. No classes tomorrow. It's some type of mental health day, and they're doing like a mental health workshop. So, yeah, yep. Anybody else have any questions about anything while we waiting to get people logged in? All right, share my screen right quick. All right. Why is it not sharing? All right. So we're going to start out with this question right here, 755. It asks you to rank the species in order of increasing nucleophilicity. Right. That's important. Increase in nucleophilicity. You watched that video last night. What's the trend, the periodic table trend for nucleophilicity? Anybody?
Like going from left to right, it decreases, right?
Huh?
And then going down, it increases.
And go ahead and say going down. And that's it. Is that in protic solvent or aprotic solvent?
Product.
So it decreases and increases in protic. And then in aprotic, it's the left to right is the same, right? And then top to bottom is the same. Is that right?
Yeah.
So that's the frame of reference that we're working from. um, so let's start out. We can run through all of these actually. Let's start out with A, and it is in A. There's no solvent indicated, right? So it's assumed to be aprotic. So you have what you're comparing here is carbon, oxygen, and nitrogen. And again, the trend is decrease, decrease, excuse me, from left to right. And then in an aprotic solvent, it's decreasing from left to right and decreasing from top to bottom. All right. So what do you think?
I think the nitrogen is the first one, right?
If we're going in order, increasing.
Oh, increasing. Oh, so um, would it be?
I think the C would be first.
Yeah.
Okay.
So if it's, the carbon is going to be the most nucleophilic. If we ranking them in order of increase, and we go from worst to best.
Okay.
So the worst is going to be either oxygen or nitrogen. And then you following? Because we're going across the periodic table. So it's carbon, nitrogen, oxygen, and then the halogens. That's the periodic group. So carbon is going to be last because it's the most nucleophilic if we're doing it in order of increasing. Right. So let's give it a scale too. Let's say from 1 to 3, where 3 is the best and 1 is the worst. Let's do that. So obviously carbon is going to be 3. Is that right?
Yes.
Because it's the best one. And then which one is further to the right? Oxygen or nitrogen?
Oxygen.
Oxygen. So that's going to be 1, and then that's going to be 2, like that. Are y'all following that?
We doing this based off of electronegativity.
No, it's just a periodic trend. It could be electronegativity. That's uh, the factor in determining how nucleophilic something is. It could be the basicity. It's really nuanced, so it's not really one factor. But electronegativity is a factor. And if you were comparing these, you could say that since oxygen is the most electronegative out of all 3, then it holds its electrons more tightly and it's less apt to donate them. So it's a worse nucleophile.
Okay. 3 is the best, right?
Yes, according to what we're doing here, right? We just gave it an arbitrary scale. Say 3 is the best, 1 is the worst.
Can you explain again? Well, I guess you don't have to.
Which part?
I'm just trying to figure out how you figure out which one is 3, 1, and 2.
Well, the scale is arbitrary. But we're ranking them based on increasing.
So far, it doesn't make me feel bad. I haven't really
Somebody's
because Beyond Meat don't make me feel bad if I eat it like Monday and Tuesday. So I start pushing it if I eat it Wednesday and
Yeah. I mean, all right. If you want to answer a question or something, just unmute.
Yeah, you were explaining that before the person who had their mic unmuted started talking.
Yeah. So the scale is arbitrary. So 3 to 1 is, or we just chose that, right? With 3 best, 1 worst. It could be anything. But we're ranking in order of increasing nucleophilicity. So we're going from worst to best and not best to worst. That's why it's like that. So the worst one, according to the scale that we just came up with, the worst is 1 and the best is 3.
Okay.
Mm-hmm. All right. So let's look at B. B asked the same question, but now you're in a different solvent. Now you're in methanol as your solvent. Big difference. Now we're in a protic solvent, so the trend is going to be different. The trend from left to right is going to be the same. It's going to be decreasing from left to right. And that's kind of, I don't know if that was Brittany. Somebody just said that about electronegativity. That's kind of in line with the electronegativity. The more electronegative the atom is, the less nucleophilic it is. So that's kind of a rough way to classify that. But in a protic solvent, as you go from top to bottom, what changes? Not necessarily the electronegativity, but something else changes.
Is it the atomic number?
The size, yeah, the atomic radius changes. So the bigger the atom is, the harder it is for the solvent to solvate it, keep it trapped, right? So in a protic solvent, bigger atoms are going to be more nucleophilic than smaller atoms because of that solvation effect. We talked about solvation last week. How the protons in the solvent kind of hydrogen bond or surround the nucleophile and kind of interact with its lone pairs. And so in a protic solvent, we want to, the bigger the nucleophile, the more apt, the more nucleophilic it is. So what do you think here? So now we're comparing sulfur, oxygen, and oxygen. Which one is, where is sulfur in relation to oxygen on the periodic table?
It's under it.
It's underneath it. So it's understood that it's bigger, right?
Right.
So of these three nucleophiles, which one is going to be the best in methanol?
Wouldn't it be oxygen?
No, sulfur is under it. So it is, the trend is in protic solvents decreasing from left to right and increasing from top to bottom. So as the atom gets bigger, it becomes more nucleophilic. So sulfur is under oxygen. Therefore, it's more nucleophilic in a protic solvent than oxygen would be. All right, so this is going to be 3. That's my best nucleophile in this solvent. And then if I have to choose between water and the hydroxide ion, which one would you pick and why? Right, one is negative and one is neutral. This we learned in part 1. Which type of nucleophile is better? Is it a neutral nucleophile or a negative nucleophile?
Negative.
Negative, right? So this is going to be 2, and then the water would be 1. Right? Both are oxygen nucleophiles, but the water is neutral and the hydroxide is negative. So that's what we'll pick. All right, let's do C. Same solvent. What do you think? Immediately you see you're comparing where your negative charge is, sulfur, oxygen, and then oxygen. Is that right? So it's the same idea from B. And we're still in a protic solvent. So which one of those is going to be the best nucleophile?
The first one.
Sulfur, right? So this is going to be 3. Uh-oh, wrong pen. This is going to be 3. And then of the other 2, which one do you think? Now, remember, if you remember from part 1, when you see this COO, right? That's an abbreviation for, I don't want to erase this. I'll move it. That's an abbreviation for like an ester or a carboxylic acid. And so it's that ester oxidation state. All right, so we look right here, COO actually looks like this: C double bond O, and then O minus, like that, right? It's that's just a way to abbreviate it. So if you compare that to this is just CH2. Which one do you think is going to be a better nucleophile? And why? This was definitely in the video that I sent yesterday. It was in one of them. What do you think? Right? What? Okay, let me ask this question. Do you think that a pair of electrons in resonance is more available for reaction or less? And why? So this is going to be 2. It's going. Oh, I'm sorry. Wrong order. This will be 2. That'll be 1. Right. This nucleophile is poor because the electrons are tied up in resonance. If they're in resonance, they're not. You can't readily donate them. Right. So that makes that a worse nucleophile than the alkoxy nucleophile to the left of it. Does that make sense? Like if you got a pair of electrons, you can see the pattern for resonance right here. Right, you can see that you have a 3-atom unit with a donor and acceptor next door, and you can push the pair of electrons here. You can push this pair here and do resonance. So while the electrons are tied up in resonance, they're less available to be donated to an electrophile. All right. Any questions so far? All right. What about D? Let's do D.
Wouldn't the first one be, well, wouldn't it go in the order of 3, 2, 1?
Let's see. We're in acetone,
Right.
which is aprotic. Right. So let's look at what the trend is for A if it's in aprotic. It's decreasing from left to right and decreasing from top to bottom. So you're right. The nitrogen nucleophile would be the best. But then when you get to sulfur and oxygen, right? If oxygen is worse than nitrogen, but it's going to be better than sulfur because it's above it, right? The solvent does make a difference. And the trend
Okay,
is
thank you.
decreasing left to right, decreasing top to bottom. So we're going to say 3 and then 2 here and then 1 here. Following?
Yes.
All right. And then E, same thing, and acetone, which is a aprotic solvent. You got oxygen, fluorine, and chlorine. Oxygen obviously is further to the left than fluorine and chlorine. So what do you think?
Will it be 3, 2, 1?
Mm.
If
Yes.
Okay.
Because chlorine is underneath fluorine.
Right.
So this is 3, that's 2, and that's 1. That's exactly right. Nice work. And then what about F in methanol? So we're back in a protic solvent. So the trend is going to be what's shown up top. It's decreasing from left to right and then increasing from top to bottom.
Would chlorine be the best?
It's to the right though.
So
It's going to be between sulfur and chlorine, right?
right.
But sulfur is under fluorine, so it's going to be better in that respect. And it's to the left of it, so it's better in that respect. So this is going to be the best. And then the fluorine, the chlorine, now we got to make a choice between those two, right? So
Dr.
yes.
Why wouldn't it be chlorine?
Because the trend is that it's decreasing from left to right. So chlorine is all the way to the right.
Mm-hmm.
Right? It's boron, and then it's carbon, nitrogen, oxygen, and then fluorine. So it's to the
okay.
further you go to the right, the worse it gets.
Okay.
Mhm. So between fluorine and chlorine and a protic solvent, which one do you think is best? Because now they both in the same position to the right, but one is just underneath the other. So it's fluorine, chlorine, bromine, iodine, and then
Wouldn't it be
yes,
bromine and
chlorine is
chlorine?
going to be better in this case, and then fluorine is going to be the worst.
Hmm.
All right. Any questions about that? All right. I want to do one other thing before we switch gears and switch topics. Um, so I want you. I'm gonna break y'all out for about 10 minutes. We're gonna do A, E, and G. 749 A, E, and G. And I'm gonna assign one question down here. Yeah, we'll do that. 2 questions. D and C up here. 834C and 834D. So if you don't have the handout, you can take a screenshot real quick. If you do have it, then you know exactly where we are. So 834C, 834D. I'm sorry, 841D, and then up top 749 A, E, and G. And this is your electrophile in each case. That's your substrate. All right, let me break y'all up real quick. Got 36 people here, so we can put 6 in a room. All right. So just go ahead and once you see the breakout room invitation, go ahead and take it. We'll come back in 10 minutes, and I'll give each group a chance to respond. All right, we got like 3 people not in a room, so go ahead and take that invitation and join the breakout room. Let's hit 10 minutes. Pause recording. So let's go up to here. Somebody from room 6. What did you get for A? It says draw the substitution product that results when butyl bromide reacts with a nucleophile.
If nobody wants to go, I can talk for another group. Nobody wants to go.
That's fine.
So for A, you basically just replace bromine with the nucleophile. So it'd be CH3, CH2, 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 OH plus BR, and the BR has its lone pairs, and it becomes negative.
Good. Excellent.
I was in group 2, I think.
All right. What about, let me have somebody from group 1 for E.
I can go again if nobody wants to go for that group.
No, we need somebody from group 1.
Okay.
Yeah. Did everybody's mic break at the same time? All right, go ahead, Brittany.
Okay, so we're on E, correct?
Yes.
Okay, so the same process, you just replacing the BR with nucleophile. So it'd be CH3, CH2, 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 negative C, and then you have the 3 pairs, CH plus the BR with its lone pairs around it, with 3 pairs of lone pairs around it, and you have the negative sign on the BR.
Mm-hmm. So with this nucleophile right here is this carbon. That's the nucleophilic part, but this happens to be triple bonded to another carbon. So it's the whole thing comes in as the nucleophile. So good. All right, let's get somebody else for G.
Okay, I'm not too sure if this is right, but I did CH3, CH2, 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 and then the little dash, and then I did NH2 plus HBr.
Okay. You know, that's not wrong, as it would start out like this. I'm glad you spoke up. That's good. So it's here. It will be here first, right? Plus Br minus, which would eventually do a proton transfer. So that's exactly right. Plus HBr. That's excellent. Who was that?
Kayla Carter.
Good job.
Thank you.
Even if you're not sure, just answer it. You don't get docked or penalized for wrong answers unless it's on the test. So it's best to get it wrong now, if it's wrong, and get it corrected. So be brave about that. So that's good. All right, let's go down to let me put it out here. It's 740. Let's go down to the bottom. I'll come back to uh 834. Let's look at 841. Somebody give me the answer to that. Somebody from a different what did I ask for? One, nobody from group 1 stepped up, nobody from group 6 stepped up. Let me get somebody from group 3. That has the answer to D. Or at least an attempt at D. Now, if you look at the question, it's asking about elimination. So you know it's an elimination. There's no question about that. And then the question is it E1 or E2? So on D, where's the leaving group?
Cl.
It's chlorine, right? And what is the bond order where the leaving group is? Is it primary? Is it secondary? Is it tertiary? What is it? So this is my leaving group right here.
Tertiary.
It's on a tertiary carbon, and it's in water, which is protein. What does that tell you? Is it going to be E2 or E1?
E1.
It's E1. Protic E1 is always done in a protic solvent. So now the question is, where are the two products going to come from? Because you're going to get two products because you got two alpha sites with hydrogens on them, right? You got a hydrogen right here, and you got two hydrogens right here, but only one of them is going to get removed in the elimination. So what would your two products look like? Don't get panicked by that ring. That's nothing. If you know the basic concept behind elimination, you find the leaving group, you find the alpha hydrogen, and that's where your double bond is going to be between those two carbons. Where those
Okay, well, the alkene will be on the left and the right side of that CH2, CH2, CH3.
you saying here?
If that makes sense. Yeah.
Yeah, it makes sense. I know what you're saying. Here, how many carbons is that? 1, 2, 3. 1, 2, 3. I'll just leave it like that. So that's one product, and you got a CH3 here. And then the other product should look like this. Right? And we already said that it was E1. All right, so you're going to get those two products, and they're going to be in competition. Which one is going to be major, according to Zaitsel's rule? Look at the double bonds in each case. According to Zaitsel's rule, the more substituted double bond is the major product.
Would it be the one on the left?
Yes. Why'd you choose that one? You're right. Why'd you choose it?
Just because it's more substituted.
Yeah, the alkene is a quaternary alkene or tetrasubstituted, right? The alkene on the left is, on the right is trisubstituted, right? You got, here's your double bond, and then it has 1, 2, 3 groups attached to it. And then on the other side over here, here's your alkene, and it's got 4 groups attached to it. 1, 2, 3, 4, right? So it's tetrasubstituted. Zaitsel's rule says that the more substituted product is going to be the major product. All right, I'm going to, do I want to leave that? No, I don't want to leave it. We got time to do it. All right, so it says, this question says that this reaction is E2. So you know that immediately it's going to be an E2 elimination. No problem. You can see right here that you have a hydroxide ion, which is going to act as your base. All E2 eliminations require a base. So where are my alpha sites here? We're just going to do that, and I'm going to let you do this one on your own. And you'll turn it in when you turn the homework in. Where are your alpha hydrogens? What do you need to find in order to identify the alpha hydrogens? What's the first thing you need to find?
Leaving group.
The leaving group. If you find the leaving group, and then you find the carbon that the leaving group is attached to, anything adjacent to that carbon is alpha, right? So this is going to be alpha position right here. This is alpha, and so is that. So how many products should I get?
3.
3 products, right? There's a hydrogen here that's going to be removed. There's 2 here. One of those is going to be removed, and then obviously there's 3 hydrogens there, right? It's not a mystery. Once you find the leaving group and the carbon adjacent to it, if there's a hydrogen there, that's where your elimination is going to take place. So that's where your double bond is going to be between the carbon that has the leaving group on it and the carbon that has the hydrogen that's right next door. That's where your double bond is going. You don't even have to know the mechanism to know how to predict the products, right? So we're gonna stop here. It's 9:54. We'll stop. I'm gonna let y'all finish that one because I think the break and breakout room means take a break, but it doesn't. But we're gonna stop there, and then on Wednesday we'll start a new topic. Uh, don't know what I think conjugation is next. So we'll start conjugation on Wednesday. I'll send y'all videos for that tonight, and then I'll open up the handout on Blackboard so you can have it ready for Wednesday. All right. Any questions before we go? No. All right. So I will see y'all on Wednesday, and you'll get an announcement with all the information for Wednesday in it. Have a good day.